Welcome to the session on genetic algorithm for problem solving. This is Vanitha from EC department. Any given problem can be solved using either hard computing techniques or soft computing techniques. A problem can be solved using a computer or a computing device, and this process we call it as computing. Hard computing is suitable for mathematical problems using mathematical models. Though hard computing is capable to solve real world problems, but it consumes a large amount of computation time and cost. This is the major drawback in the case of hard computing. On the other hand, the soft computing is used to solve nonlinear problems which involves uncertainty, and these type of problems we consider as real life problems, and it requires intelligence to solve. Soft computing techniques can be categorized into three types. The first one is fuzzy logic, artificial neural networks, and the third one is evolutionary algorithms. Under this, we have genetic algorithm, the topic which we are going to see now. Genetic algorithm is defined as an algorithm that solves a problem by finding an optimized solution which is based on the theory of natural selection. It's an excellent algorithm to search through large and complex data sets. And a very important characteristics of genetic algorithm is that it is capable to find a reasonable solution for complex problems. This is the flowchart for genetic algorithm. We consider the possible solutions and we call it as population, and we evaluate the solutions based on the fitness function, and we check whether we have obtained optimal solution. If optimal solution is obtained, then the process ends here. Else, the following process is performed. In the first step, we select parent 1 and 2 from the population, and parent 1 and 2 undergo mutation or crossover or both the operations, and children are formed. The children formed, again they are evaluated to check the fitness, and if optimal solution is obtained at this point, then the process ends here, else the process repeats. Let us take an example of traveling salesman problem and solve by using genetic algorithm. Let us take the simple case in traveling salesman problem. Let us consider four cities, and we consider that the cost of travel between cities are known. The main objective is to visit all the cities but only once, and the total traveling cost should be minimum. This is a given problem. We have four cities, 1, 2, 3 and 4, and 10 is the traveling cost between city 1 and 2, and also it is going to be the same cost to travel from city 2 to 1. So that is a similar case between 2 to 3, 3 to 4 and 4 to 1, and also there is a path between 1 to 3. But note here, there is no path between 2 to 4 or between 4 to 2. Let us consider few possible solutions for this problem and it is considered as population. For example, one possible solution is 1, 2, 3 and 4. And we consider the fitness function as summation of traveling cost. So this is a very simple case we consider to make the problem simple for analysis. And by considering this as the fitness function, we evaluate the fitness function for the first case. So for the first case, the traveling cost between 1 and 2 is 10, between 2 and 3 it is 20, and between 3 and 4 it is 30. Putting all together, it is 60. So similarly, the other fitness functions are evaluated. The population is ranked based on the fitness function. Since our objective is to determine the minimum cost, hence the minimum cost is given the rank 1. Similarly, the next is 2 and next is 3. Now iteration 1 starts here, which starts with the selection process. We are selecting two parents based on the rank. So rank 1 and 2 are selected. Step is crossover. In this step, the genes are exchanged between parent 1 and 2. By exchanging 2 and 3 with 2 and 1, child 1 and 2 are formed. After crossover, we can see here the two genes, that is values appears to be same. Therefore, one value is replaced by the missing value. In this case, since 3 is missing, we replaced 1 by 3. And in this case, 3 is replaced by 1. Hence, we have obtained child 1 and child 2. And now we have to evaluate the children. We can see here that 2 appears after 4. And initially we have seen that there is no path between 4 and 2. Since both children 1 and 2, we have 4 and 2, both the children cannot be accepted. Hence, both the children are discarded and we proceed to iteration 2. Iteration 2 starts with selection process. Since we have already taken 2 parents for iteration 1, the remaining 2 parents we consider for iteration 2, parent 3 and 4. This crossover between parent 3 and 4. And after crossover, we have obtained child 3 and 4. We evaluate the fitness function for child 3 and 4 and we find it to be 55. Since it is an optimal solution, the process ends here. These are some of the applications where genetic algorithm is used. In the next session, we will see how genetic algorithm is used to solve real-time problems. Thank you.